In this example, we'll consider a continuous mass distribution, right? Consider density distribution of the form rho r is equal to rho 0 r divided by r, cap R, to the minus 1.5 for r less than r. And rho is some constant, and rho equals 0 for r greater than r. Find m of r, the mass enclosed inside of r for such object. So this is some object. It has some radius r. Okay, it's empty out there because rho of r equals 0 there. Okay, and inside of it, basically, rho goes like rho 0 r over r to the minus 1.5. All right, so let's consider the mass. And once we get the mass of the function r, we can get basically the gravitational acceleration of the function of r. Okay, so let's do this. So this is m of r is equal to integral of 4 pi r squared, okay, rho of r dr, right? Called the classic important result that we need. Okay, so once we have this, we can basically set this equal to integral of 4 pi r squared. Now rho of r, what's rho of r? Rho of r is just going to be rho 0 r over capital R to the minus 1.5 dr, right? Okay, so I'm going to factor this stuff, break this thing up. Basically going to be 4 pi rho 0 factors out of 1 over r to the minus 1.5 integral r squared r to the minus 1.5 dr. Okay, well this is just r to the 0.5 dr, and this 1 over r of minus the 1.5 is just going to be r to the 1.5, 4 pi rho 0. Okay. Alright, so now this thing is actually something pretty simple. This is going to be basically, remember our way of method of integration is going to be 1 over 0.5 r to the 1.5, right? Plus some c, okay? Alright, be 4 pi rho 0 r to the 1.5, alright? Or in other words, 1 over 0.5 is 2. This is going to be 8 pi rho 0 r to the 1.5. R again, little r to the 1.5. Now c is actually something that you can just determine. Imagine your r equals 0 at the very center. What's the mass you have? 0. We've got 0. This is 0. M of r should be 0 at r equals 0. So therefore c is equal to 0. So that's your final answer. Something like this is acceptable. But you can actually get something a little further along. Suppose at m of r, we set this equal to r to m, wherever that m might be. Okay? And let's suppose we say that. So m of r is going to be 8 pi rho 0 r to the 1.5. Now this r becomes capital R to the 1.5 again, which you can rewrite as something very simple. 8 pi rho 0 r cubed. Now if you write like that, and you set this equal to that, so this entire thing is m, little m, like I mean capital M of little r, is just going to be basically m r over capital R to the 1.5, which is a significantly simpler way of writing it. Okay, either of these things were acceptable, but from either of these you can actually determine what the gravitational force needs to be. Hope that was helpful.